Okay, so we're going to start class 14, which is going to continue to talk about functions and their graphs. So here I have what's called a piecewise function, and each piece of this function is a different line. So we've got this piece, and we've got this piece, and then you've got this little piece right in there. So each of those lines has its own equation. So let's just remind ourselves how to find the equation of a line. So we can call this piece 1, and this guy we'll call piece 2, and this guy we'll call piece 3. Okay, so if I want to find the equation of a line, it generally has the form y equals mx plus b, and m represents the slope and b represents the y-intercept. So for line 1, if I start with y equals mx plus b, the first thing I have to figure out is the slope. And you can find the slope by using 2 points. So the slope of this line is the change in the y-coordinates over the change in the x-coordinates. So my y-coordinate of 8, that's the y-coordinate of my first point, 20, 8. And then this point down here is 0, 2. So my second y-coordinate is a 2. And then the change in my x-coordinates is going to be 20 minus 0. So my slope is 6 over 20, or 3 over 10, 0.3. So my equation will be y equals 0.3x plus b. And then your y-intercept you typically find by taking either of your points, or any point on the line, plug in the x-coordinate for x and the y-coordinate for y, and you can figure out what b is. So I'm going to use the point 0, 2 because plugging in zeros is pretty easy. So my y-coordinate is 2, 0.3 times 0 plus b. So 0.3 times 0 is 0, so it turns out that b is 2 here. That's my y-intercept. So the final equation of that line 1 is going to be y equals 0.3x plus 2. Okay. So I'll leave you to do line 2 and line 3. We're going to move on to the demo. I just wanted to give you a brief refresher on how to find the equation of a line. Alright, so sometimes a function needs more than one formula to accurately model a real-life situation. For example, taxi fares, or the U.S. federal tax code, which varies based on income, late fee charges for a credit card based on what your balance is or how late it is. All of those things require a function that uses more than one formula to model them. So in these situations, the function is defined on different pieces of the domain, so we call it a piecewise function. The graph below represents a piecewise function. It shows the amount of water in thousands of gallons in a swimming pool after t hours have elapsed. So this is the same graph that we were just looking at in the preview exercises. So if we want to look at how is the amount of water in the pool changed from 0 to 50, so from time 0 to time 50, from 0 to 20, from time 0 to time 20, the amount of water in the pool was increasing, right? And then from time 20 to time 30, the amount of water in the pool was constant. Right here, the amount of water in the pool was constant at 8,000 gallons. And then from time 30 to time 50, over this time interval right here, the amount of water in the pool was decreasing, so it was draining. So it increased, then it stayed constant, and then it decreased. Right. So over what interval is the water level increasing? Well, that happened from time 0 to time 20. And then when was it constant? That was 20 to 30. And then decreasing 30 to 50. Those three intervals, 0 to 20, 20 to 30, and 30 to 50, those define the different pieces of the domain for our function where we would need a different formula. We would need 3 different formulas to describe what was happening in this situation. So we can represent the pool problem by writing the number of gallons in thousands, G, as a function of the number of hours, T, using a piecewise function. Okay, so this is some brand new notation. So you can recognize the intervals over here on the right. These are the important intervals, 0 to 20, 20 to 30, and then the last one was 30 to 50. Actually, typically you don't repeat the or equal to in 2 places. So see, I have less than or equal to 20 right here. In the next line, it's just a strictly less than sign that I wrote. So if I use less than or equal to 30 in one line, my next line should be 30 less than t less than or equal to 50. It's not a hard, there's nothing wrong with writing the equal sign. It's just it'd be equivalent to like using poor grammar in English. Okay, so you might notice this first formula, 0.3t plus 2, that's the equation that we found earlier. And if you actually did pause the video and find the other 2 equations of the other 2 pieces of line, then you would have gotten 8 and negative 0.4t plus 20 as your other 2 equations. So this is our typical notation for a piecewise formula. You would name the function, so in this case we named it g of t, but you name the function something like g of t or f of t, then you put an open curly bracket, you put formulas, and then you write if after the formula, and then you give an interval of when that formula applies. So if my cell phone plan with Verizon Wireless is $79 a month, and for that $79 I get 700 minutes, but any minutes over that 700 are charged at 45 cents a minute. C is going to represent the monthly cost in dollars, and little m is the number of monthly minutes used. Let's see, what is C of 535? So that's, what am I going to get charged if I talk for 535 minutes? Well, in this case, just $79, because 535 is less than the 700 that I pay for, so this is 79. So to interpret 535 minutes costs $79. All right, but let's see, if I wanted to figure out my charges for 850 minutes, I would have to say, well, I'm definitely going to get charged my $79. I pay that no matter what, right? But then I'm also going to get charged for the minutes that I went over 700. So I'm going to get charged for 150 extra minutes. So 150 times 45 cents for each one. And that's going to come out to $146.50. So my interpretation is that 850 minutes costs $146.50. So now that I have figured out how to calculate my cost for any number of minutes, we could do this no matter what number of minutes they give me, I can write a formula, a piecewise defined formula for C of M. So I've started the notation here for you. I have C of M equals, and I have a big bracket listed. And there are going to be 2 different formulas. One if you talk for 700 minutes or less, and you have to use a different formula, a different rule, if you talk for more than 700 minutes. So the first one is the easy one. If you talk for less than 700 minutes, your cost is $79. There's no calculation at all. So my C of M is 79 if M is less than or equal to 700 minutes. But if I talk for more than 700 minutes, I have to pay the $79 plus 45 cents for each minute that I go over 700. So if M is representing the total minutes I talk, I have to take that, subtract the 700 I already paid for, and then do 45 cents per minute on the amount over 700. So that's my formula if M is bigger than 700. Okay, in our last example, I'm going to give you a piecewise defined formula. I'm giving you the algebraic definition, right, with the standard notation. F of x equals, I have a squiggly bracket, and then we've got two different formulas. X squared when x is less than 1, and 1 minus x when x is bigger than or equal to 1. So what I typically do is I pretend that they just asked me to graph y equals x squared, right? So I'm going to have y equals x squared. You make a little xy chart, or maybe you already know what x squared looks like. That'd be great, but if you don't, you can just pick some random points and plot them. So maybe I'll do like -3, -2, -1, 0, 1, 2, 3. Plot these points. So I'm going to take each of these x's, plug them into x squared, and I will get the y value. So -3 squared is 9, -2 squared is 4, -1 squared is 1, 0, 1, 4, 9. Okay, so I'm going to plot these points. I've got -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. About right there. -3, 9. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. Okay, so then I would just connect those with a nice smooth curve. All right, and then, let's see, I'll use another color for now for the other formula. My other formula is y equals 1 minus x. So make a little xy chart. You might know how to graph the this is a line. You might know how to graph that right off the top of your head. That's great. And if you don't, just pick a few x values. Maybe 5 and 0. 0 is always a good one. So I just picked those off the top of my head. 1 minus 5 is -4, and 1 minus 0 is 1. And because I know this is a line, I know I only need 2 points to know what it looks like. So 5... 1, 2, 3, 4, 5, -4. 1, 2, 3, 4. There we go. And 0, 1. Right there. So this is a line. Just takes 2 points to determine a line. So I just connect those best I can with a straight line. There we go. Okay, now I have to determine which parts of this graph I actually want to keep. So, according to my formula that I was given, I'm only supposed to graph x squared when the x value is less than 1. So I need to erase all of the parts of that graph where the x values are bigger than 1. Okay, so I need to erase Alright, so I need to erase the part of the graph for x squared where my x's are bigger than or equal to 1. So I just got to erase this part over here. Just do the best we can to erase all the parts of that graph where the x values are bigger than 1. Alright, and then for the blue graph, the graph of y equals 1 minus x, I only wanted to graph that when x is bigger than or equal to 1. So everything to the left of 1, I need to erase. So I'm going to erase all of this part. Up until I get to the x value of 1. Okay, so the important number that I was looking at there was x equals 1. So on the x-axis, I was looking at 1. And then I kept the orange graph to the left of 1 because it says x less than 1, and I kept the blue graph to the right of 1 because it says x greater than or equal to 1. And then I can kind of combine these into one graph just to make it really clear. This is the graph of the piecewise function. Okay, you can get started on your class activities. These get progressively more difficult, and the last one, number 4, is particularly difficult. And if you get stuck, don't spend more than 15 minutes or so trying to work through that problem. If you get it, that's awesome, but if you don't, I will never quiz you or test you on something that difficult. As usual, that you do have the answers after the class activities.